हेलो स्टूडेंट्स, स्वागत है आपका डॉक्टर सौरभ सर क्लासेस में। और आज हम लोग सॉल्व कर रहे हैं ISI MTech PCB सॉल्यूशंस 2025। और इस सीरीज़ में हम लोग आ चुके हैं क्वेश्चन नंबर 9B में। तो यहाँ पे क्वेश्चन दिया गया है कि प्रूव दैट द लैंग्वेज L इज़ नॉट रेगुलर, यू मे यूज़ द फैक्ट दिस इज़ नॉट रेगुलर। ओके, सो टू प्रूव अ लैंग्वेज इज़ नॉट रेगुलर, व्हाट वी कैन यूज़ ईदर ऑफ द फॉलोइंग, लाइक pumping lemma, closure properties of regular languages, and reduction from a known non-regular languages. Okay, so we will use a closure property approach here and reduce from the known non-regular language. Okay, so if you recall the closure properties, like closure properties, so here if regular languages are closed under intersection, that is one. If closed under homomorphism, this is there. And if it is closed under inverse homomorphism, so then what is that? If a known non-regular language can be reduced to another language using inverse operations that preserve regularly, so then the target language cannot be regular. So we will define the known non-regular language. Let's consider here L is equals to a to the power n, b to the power n, given n, this is equals to 0. Correct? Using this is a not regular, I consider. Okay, so then we will have to show reduction from this to n. So we define a homomorphism or intersection to extract L from this. Okay, so let's define a language like this being power n, b to the power n, n greater than this. Okay, so that is L, a to the power n, b to the power n. So 2n is a perfect square. Okay, so what we observe here, this one. Now we have to observe that this one, and if L were regular, then this would be regular. Okay, and if it is not regular, but the condition that 2n is a perfect square cannot be tracked by any finite automation. So what we need, we would need unbounded memory to check whether 2n is equal to k square. So contradictions, that is, if L were regular, then this would be regular. Correct? But we know that this is not. So alternative argument, that is pumping lemma. Here, assume L is regular. Okay, then by the pumping lemma, there exists a pumping length P such that any string, this represents L with, so it can be written as S is equal to XYZ, satisfying what? This, then, and XY means L. Okay, for all I this 0. Okay, so we have to pick S is equals to a to the power this, b to the power this, such that 2k is equals to k plus k, that is k square. So here k is what? 2, k is what? 4, etc. like this. So apply pumping to the A block, it leads to string with more A's than B. So sum is not a perfect square, so there is a contradiction. So L is not regular. So finally the language is not regular. This is the final answer.